Right, last class we are discussing that alkenes, right? In the alkenes preparation, dehydration takes place, right? Dehydration of alcohols. When dehydration of alcohols, we are using concentrated H2SO4 in 440 degrees centigrade, right? Along with concentrated H2SO4, so we can use these reagents also, no? So you can write it down, these reagents also. Sometimes they'll give you this type of reagents, write it down. Concentrated H2SO4 at 443 to 453 Kelvin, H3PO4, Al2O3, heating with P2O5, P4O10, heating with POCl3, heating with KHSO4. So all these reagents we can use for the dehydration of alcohols, but mainly we will use the concentrated H2SO4 at 443 to 453 Kelvin. So because some advanced cases they'll use different types of reagents, but mainly this is enough. Of course, just write it on this. Heating with P2O5 or P4O10, POCl3. Next, Nana, dehydration of alcohol, the order would be like this. 3 degree alcohol is more than 2 degree, then 1 degree. So means the order is like this. The OH, CH3CH, CH3OH, CH3CH2, OH. For example, this is 3 degree. This is 3 degree, 2 degree, this is 1 degree. Because dehydration in alcohol. When dehydration, 3 degree alcohol, sir. So in this case, no? Because this carbocation is going out, so first one, second one, just is done. Ease of hydrogenation. Write it down, ease of hydrogenation. Sometimes a 6-membered ring, 5-membered ring, like 4-membered ring. In these 3 cases. Also 6-membered ring, more stable. So ease of hydrogenation, write it down. And ease of hydrogenation, for example, CH3, CH2, OH. For example, if I am taking the secondary alcohols, if I am taking the tertiary alcohol. So in this case, Nana, so temperature we can use here. Temperature, it is 180 degrees. 180 degrees. It is 165 to 170. 170 degrees centigrade. Here, just 85 degrees is enough. So in this case, we can use the reagent is concentrated H2SO4. In this case, 85% of H3PO4, or we can use 85% of H2SO4. In this case, 20% of H2SO4 is required. Right? In this case, this is undergoes E2. E2. In this case, E1. E1. So we know the product is CH2 double bond CH2. This is the product, this one, CH3, CH3, double bond CH2. Elimination reactions are E2. This is E2, E1, E1. Elimination reactions are 3 types, E1, E2, E1, Cp. Acid concentration. acid concentration. See, Nana, in this case, when we are taking the 3 degree, what exactly happens? So less temperatures are favorable and less concentration is also enough. But whereas in case of 1 degree case, high temperatures are needed and more concentration of H2SO4 is required. So next one of the important reaction this. HOH here is, and here is HH, and here is HCH3. Okay. In this case, Nana, so if you are using a H plus acidic medium, water is going out. So imagine if OH and pink hydrogen, if it's going, so what product we will get? Here we will get the double bond, and here is CH3. And in this case, if the green hydrogen, the green hydrogen is there, CH3H, like this. In these two cases, which is more stable? In these two cases, which is more stable and which is more major product? Which is major product? A and B. This is A, this is B. So this is exactly more substituted alkene, right? How many alpha hydrogens are here? How many alpha hydrogens here is 2, and that is 3. Total 7. 7 alpha hydrogens. But whereas in this case, Nana, 1, 2, 3 alpha hydrogens. 3 alpha hydrogens. So basically this is Saitjev product. Saitjev's products. Saitjev's product. This is Hoffman product. Hoffman product. Yesterday I explained when we are using the bulk base, we are using the Hoffman product. So, but this is exceptional case. Put 5 star. Put 5 star. Exceptional case. Exceptional case. Write it down. So let me know. So which is major product in this case? So here is the stereochemical requirements. Stereochemistry we need to cross check. So this OH, right? The anti group. So along with OH, so the remaining the hydrogen. So we need to remove this is anti position. Hydrogen should be in anti position. Hydrogen should be in anti position. Anti position means what? So this is correct one. This hydrogen is correct. So whenever the elimination reaction takes place, in the beta elimination, for example, the OH, then H should be in the opposite direction, right? Anti position, right? Anti position should be there. Anti position. So this is wrong. This is right. So means this is major product. Major product. So a lot of times what we'll think is a more substituted alkene is major product, but in this particular scenario, so this is correct. Write it down, 5 star question. So whenever the elimination reaction is done, means elimination, beta cases, anti should be present, right? Hello. So for example, the OH, H, So which H we should remove up? Down one or green one? Along with this OH, this H plus is going out. Anti-position. Both should be in the anti-position, but not this hydrogen. Write it down. Always, whenever we are doing the elimination cases, opposite direction. It should be anti-position. Write it down. So, lot of times they are asking this type of questions. In this case, write the major product, major and minor. Write major and minor products. Alkene only is forming, so let me know the major and minor. So first the OH is going out, right? First this OH is going out. What exactly happens, Nana? CH3, CH2, C. So I'm just writing the phenyl group. Otherwise, I'm just writing here itself. So here is the carbocation is forming, right? Now the thing is, either phenyl shift or methyl shift. Which one takes place? What we need to do? Methyl shift is correct, or phenyl shift. Which one is correct? Which one is correct? Anyone? Online guys. So if I am doing the methyl shift, this will get like this. If I am doing the phenyl shift, what exactly happens? Let me know the two carbocations which are forming, which is more stable now. Which is more stable? First one or second one? Which is more stable? See, we need to cross check whenever the mesomeric effect, then hyperconjugation, then inductive effect. So mesomeric effect or resonance, right? First we need to cross check with resonance. So then hyperconjugation, then inductive effect. So hyperconjugation means number of alpha hydrogens we will cross check over there. But first we need to cross check whether the resonance is there or not. When the resonance is present, that is more stable. So obviously the first one is more stable. Okay? Because this carbocation is resonance stabilizer now. I'm just writing the phenyl group like this, double bond, CH3, CH3. Obviously this would be forming the major product. Whereas in this case, CH3, CH2, CH3, double bond C, right, PH, CH3. So this will show the geometrical isomerism. Is this showing the geometrical isomerism? The first one is showing the geometrical isomerism, yes or no? The first compound, is it showing the geometrical isomerism? Methyl, same groups are there. It won't show the geometrical. It shows the geometrical, cis and trans. So alkenes, cis and trans are called as enantiomers or diastereomers. Alkenes, for example, cis and trans are possible. Those are enantiomers or diastereomers. Enantiomers is not possible because it should be having the chiral center and all. So these are diastereomers. So cis and trans. Diastereomerism, cis and trans both are not mirror images, not superimposable, right? Those are what? Diastereomers. Diastereomers. They'll show the cis and trans diastereomers. Dehalogenation. Vicinal or geminal. For example, vicinal, geminal. Two halogens are same carbon, those are geminal, right? Or anything, zinc dust, zinc in presence of acetic acid. Or ethanol also we can use. So we'll get alkene. ZnCl2 is going out. pH2. ZnCl2 is going out. Otherwise, we can use like this also. pH3. So same product we will get. ZnCl2 is going out. So D, coal base electrolysis I already told you, right? So will you try the coal base electrolysis once again? Write it down, coal base electrolysis. Coal base electrolysis. Coal base electrolysis. Electrolysis. So we can take like this, write the products. Did you write the products this? The byproducts will be same. So write these products in dehydration once again. Let me know the, for example, here is the product, concentrated H plus. Write it down. Let me know the product. Write these two products. In this case, what happens in the first case? I'll explain. Here is the carbocation is forming, right? Now, so how we have to do the ring expansion? 1, 2, 3, 4, 5, 6. I'm just writing the 2 is going to attack at the first position. Directly write the 6-member ring. So 1, 2, 3, 4, 5. So as your wish, anywhere you can write the numbering, doesn't matter. And this first position methyl group is there. Second position carbocation. Yes or no? So the carbocation rearrangement takes place. Why? 3 degree carbocation. Here is the carbocation. Then automatically anything is possible. Left or right, both are same. Write it down. Next, elimination reactions are, I already told you. Elimination reactions are two types. Alpha elimination, beta elimination. Beta elimination, once again, I told you, 3 types. E1, E2, E1CV. What is alpha elimination? Alpha elimination means if you are eliminating the 2 atoms or groups from the same carbon. For example, chloroform, if I am taking, here is the Cl minus and H plus, right? We are removing from the same carbon PCl2. Dichlorocarbene we will get. Dichlorocarbene. Dichlorocarbene. Alpha elimination. So here is alpha elimination not needed, but we'll go with the E1, E2, E1CB. Beta elimination is important. Beta elimination. Beta elimination lo E1. So E1 means, so same like SN1, but if people don't know, right, let it be, but try to understand. So OH plus we can take living group, nothing but OH, anything we can take. In E1 nana, so first what exactly happens, right? The slow step. First slow step we are called as RDS, rate determining step. The rate determining step, first living group is going out now. This is going out. Positive charge. So first we will get like this. So then afterwards in the first step, base is coming and obstruct this proton. H plus is taken by this base. This bond is coming over here. Okay. What we will get? C double bond C like this. Alkene we will get. This is first step. First. So in this case, which base we will use? Weak base we will use. Weak base. More stable alkene is major product. Here, write it down. More stable alkene. More stable alkene is major product. More stable alkene is major product. So in E1 3 degree, 2 degree, 1 degree this takes place. Weak base and rearrangements are possible. Rearrangements are possible. Whenever the carbocation is coming, rearrangements are possible by default. Ring carbocation is coming. If it is possible, ring expansion is specific cases only it takes place. Ring outside carbocation is there, that would be either 5-membered or 4-membered. In case of 6-membered, no ring expansion. So write one more point, whenever the carbocation intermediate. So carbocation intermediate. Carbocation intermediate. Rearrangements are possible. Like I already explained earlier here, right? Where? Here. So E1 is takes place when 1 degree, 3 degree and 2 degree cases. 1 degree is there, E1, E2 is takes place, 1 degree cases. Okay. Next one, E2. E2 cases. What exactly in E2 cases? Right, leaving group, hydrogen, flow step, RDS. So here is base is coming here itself. Base, earlier base is coming in the first step. So in this case, Nana, so all are going at a time. So base is coming, taking the hydrogen. This bond is coming over here. So this is going, all are taking at one place. Means at a time. At a time. Right? This is, we could say, incipient alkene, incipient or baby alkene, like that. So then afterwards, alkene is forming, of course. Means what we need to understand, at a time hydrogen and leaving group going simultaneously. But whereas in case of E1, first leaving group is going out, then afterwards hydrogen. Write it down. E1 CB Nana, last. This is important, Nana. This is exactly opposite to that one. So generally when we have the poor leaving group is there, we will use that. So here in this case, base we will use the slow step only. So first base is coming and taking the H plus right here. So means what? Negative charge is coming over here. So L. Okay, acid base reaction takes place first. So then in this case, this negative charge is coming over here. So the leaving group is going out. We'll get the alkene. We'll get the alkene like this. Write it down. What is the leaving group? Should be poor leaving groups, Nana. Poor leaving groups like fluorine, OH. Like this. These we will use as a poor leaving groups. These are poor leaving groups. Write it down. Poor leaving groups. So carbene ion is as an intermediate, right, in this case. The important thing is in E1 carbocation intermediate, here is carbene ion intermediate. So we should know which stability of carbene ion. So we know that, right, carbocation 3 degree, 2 degree, 1 degree. Even carbon radical also 3 degree, 2 degree, 1 degree. But whereas carbene ion opposite, 1 degree is greater than 2 degree, 3 degree. Write it down. This is always, you need to remember this. For example, write one example. CH3, CH2, CH. This is we are using the base, strong base only we are using. So for example, OH minus. Let me know, here is 2 hydrogens are there. Right, I'm just writing the hydrogens are like this. Here is the white hydrogen. Here is the red hydrogen. Which hydrogen we need to remove? Along with leaving group. This is leaving group. First, if it is going like this, CH3, CH2, CH, N, CH2, negative charge. So which carbene ion this is? 1 degree carbene ion. 1 degree carbene ion. If we can take a red hydrogen, CH3, CH, negative charge, CH, CH3. This is which degree, Nana? 2 degree, 1 degree. So then this is coming here. This is going. So we'll get a Hoffman product is major product right here. Hoffman product means what? unstable alkene, right? Least substituted alkene. This is major over here. Major. In this case, this is Hoffman product is major product analysis. In this particular case, depends on conditions, it's changing, of course. Write some examples. So we need to identify based on the living group, right? It's easy task. Write these products as a homework. One, two, three, 5 question. Come on, write it. Sixth one is 5-star better. So write this, Nana. So remaining things I'll discuss tomorrow. Okay.